welcome back to the channel. So today in this video lecture we're going to be solving this problem, swim in rising water. So in this problem we are given a grid of dimensions n cross n, where each element in this grid represents the elevation at that point, namely the elevation of the water. Now the rain starts to fall at time t. The depth of the water everywhere is t. You can swim from a square to another 4 directionally adjacent square if and only if the elevation of both squares individually are at most t. Now that means from any cell in the matrix we can move to its adjacent cell only if the elevation of both the squares or both the cells individually does not exceed this limit t. Now what do we have to do is to return the least time until we can reach the bottom right square if we start at the top left square, that is 0 0. Okay, so that's the target. How can we solve this problem? Let's better understand the problem statement using an example. Let's take this example. In this example we have a matrix of dimensions 2 cross 2, and here we want to find, basically what do we want to do is we start from this cell 0 0, we want to reach this cell 1 1, and we want to find such a path such that the water level along that path, the maximum water level along that path should be minimum. Like here there are two paths, one of them is this, and the maximum water level is 3 along this path. Another path is this, that is move like this, and the maximum water level along this path is also 3. Now we want to take minimum of these two maximums, and that would also be 3, and hence 3 is the answer for this test case. Okay, that's what we want to do. Let's take another example here, one more example. So here in this example we have like a matrix of dimensions 5 cross 5. Again we want to start from the cell 0 0, we want to reach cell 4 4. Okay, this contains 6 and this cell contains 0. Okay, okay, so let's take this example. There are multiple paths, one of them is this, and along this path the maximum water level is 24. Another path is this, and along this path the maximum water level is 20. Another path is this, and the maximum water level along this path is 22, and so on. The optimal path for this test case would be this. Okay, like move all the way from 0 0, from cell 0 0 towards right, then towards bottom 2 units covering these 3 cells, then move all the way to the left, then again move downwards 2 times, and now finally move towards right all the way to the rightmost cell and arrive at the cell 4 4. Now along this path the maximum value is 16. Okay, now this is my answer. What will be my answer? There will be multiple paths where for each path will have some maximum elevation point or maximum elevation level of the water, and out of all those maximum levels I will choose a minimum of them, and for this case, for this matrix, the minimum is 16, and 16 is the answer for this test case. Okay, so that's what we want to do. So you got the idea what we want to do in this problem statement. So how we're going to solve this problem is, like, one of the strategies like that comes to the mind when we want to traverse starting from a given source vertex to some destination vertex, such that we want to find the maximum integer along that path, is basically to explore the paths like here, like one of the strategies to solve these kind of problems is use so single source shortest path algorithm, because here we have a source cell or a source vertex, we have a destination cell or a destination vertex. We want to reach this cell, we starting from this cell, and we want to find such route such that along that route the maximum number is minimized. Okay, so this is the problem is very similar to finding the shortest path from the from a given source till a destination. So how we're going to do that is simple. We'll take a priority queue, and into that priority queue I'm going to push this cell, that is the cell, the source cell 0 0, along with the maximum distance till now, the maximum distance or the maximum, sorry, the maximum elevation level. Okay, along with the maximum elevation level, and here for this cell 0 0 the maximum elevation is 0. So what I'm going to do is, whatever path I am choosing, so for any cell on which I am standing, what I'm going to store is the maximum elevation level which I have encountered to reach that particular cell on which I am standing. Like here in this case I am standing on cell 0 0, and the maximum elevation level is 0 for this cell. Okay, so now in the priority queue we have cell 0 0, its elevation level is 0. Now pull this cell out of this priority queue, okay, and explore its adjacent neighbors. So for cell 0 0 explore the adjacent neighbor, that is cell 0 1 and the cell 1 0. So for cell 0 1, which is this, simply push this cell into the priority queue, cell 0 1, and along with the updated time or updated elevation level, and it would be 1, because for the cell from which I am coming, that is cell 0 0, the elevation level is 0, and the elevation level for cell 0 1 becomes 1. Okay, then explore this cell, that is 1 0, and also push this cell along with the updated elevation level, which is 24, because max of 0 and 24 is 24. That is, to reach cell 0 1 the maximum elevation which I have encountered is 1, while to reach cell 1 0 the maximum elevation level that I have encountered is 24. So you got the idea. What I'm trying to do is, to reach any cell in the given matrix, I'm trying to figure out the maximum elevation level which I have encountered. Now out of these two pairs I will pull this pair out of the priority queue, this one, because I am using a min heap. Now from cell 0 1 till I reach cell 0 1, the maximum time or the maximum level which is here is 1, the maximum level is 1. Now from this cell 0 1 I will traverse its adjacent cells which are not visited yet. So I will keep track of the cells which I have already visited. So I have visited cell 0 0, now I have visited cell 0 1 and 1 0. Now I am visiting the adjacent cells of cell 0 1, which would be this, that is cell 1 1, and this, that is cell 0 2. Okay, so from cell 0 1 I will visit cell 0 2, then I will visit cell 1 1. Now while I visit cell 0 2, the maximum level becomes 2. So push this cell, which is the cell 0 2, with the maximum elevation level till this point, which is 2. Also traverse this cell 1 1 and push this cell into the priority queue along with the maximum elevation level to this point, which is 23. Okay, so in this fashion I will keep popping out the top cell from the given priority queue. Now out of these three cells, I will pop this cell out of the priority queue, the cell 02, and its maximum elevation level till this point to arrive at cell 02 is 2. Okay, so I have to reach cell 02 here, and the maximum elevation level is 2 at this point. Now from this cell 02, traverse its adjacent cells, that would be cell 03 and the cell 12. So visit these cells. So for cell 03, push this cell into the priority queue. 03 would have 03, and the maximum elevation level till this point is 3. Fine. And also visit this cell 12, and the maximum elevation level becomes 22. So I hope you got the idea what I'm trying to do here. So in this fashion, while I so in this fashion, I am basically exploring all of the possible paths. I'm exploring all of the possible paths. So the most optimal path would be this. So you got the idea what I'm trying to do here. I'm simply visiting the neighboring cells of the given of the cell on which I am currently standing, and for those neighboring cells, I'm basically updating the maximum. I'm basically updating the maximum level which I have encountered till now, and out of all those maximum levels, I'm gonna simply return the level which is minimum. Okay, like to reach the cell 6, the path which will be most prioritized will be this, that is this one. This will be the path which will be most prioritized, this one, because along this path the maximum level encountered is 16, and this is a minimum. Why it will be prioritized first? Because I am using a min heap. Okay, so this will be the most optimal path to reach the destination cell. So I will, so whenever I encounter, so while popping out the cells from this priority queue, whenever I encounter the cell 44, which is the target cell, I'm gonna simply return the maximum level associated with that cell, because that will be the minimum possible level which I can get, which I can have along the most optimal route to reach the cell 44. Fine, because this is basically the property of priority queue. It prioritizes the items, it prioritizes the cells according to their distances, according to this first variable, according to the elevation. And when I arrive at this cell along this path which I have traced out, 16 will be associated with the cell 44. Okay, and I will simply return this 16 right from there. Fine. So let's just see the implementation of the idea explained here. So this is the implementation. This is the swim water function, and in this function I am passing a grid. I'm calculating the dimensions of this grid and then declaring a priority queue. These are the direction vectors which will be used to navigate to the neighboring cells. Then I just push the source cell into the priority queue along with its value. I create a visited array and initialize it with 0 so that I do not revisit a cell again. Then I simply run this while loop till the priority queue is not empty, and again pull out the top node. They are ordered according to their distances, according to their elevation levels. Pop that node out of the priority queue, then separate the three elements of the given tuple. The first is the elevation level, the second is basically the pair representing the coordinates of the current cell. Then check if the coordinates corresponds to the ending cell or the bottom right cell. If it is the case, then return the elevation level associated with this cell. Then finally iterate over the adjacent cells of the current cell, and for the adjacent cells calculate the dimensions of the adjacent cells. Check if it is a valid cell. If it is a valid cell and it is not visited, then simply visit it and push it into the priority queue while updating the elevation level, the best elevation level till this cell. Like here, what I am doing here is I am simply taking the max of the elevation level for the previous cell from which I am coming and the elevation level for the current new cell. Okay, so I am simply taking max of these two cells. So finally, that's how my function is working. Let's jump to the code implementation part. Okay, so this is the swim water function which takes in this grid. Let's calculate the dimensions of this grid and represents the number of rows in this grid. Then M represents the number of columns in this grid. Then let's declare a priority queue. Okay, so vector of vector, it is a min heap. Pass in the comparator. Now push the source cell into the priority queue. The source cell is grid 0 0 along with its dimensions, which is also 0 0. Now declare a visited array of dimensions n cross m initialize it with 0 and visit the very first cell, which is the source cell. Now iterate over the priority queue. Pull out the top cell from the priority queue. Then segregate these three elements, that is the time or the elevation level for the current cell, that would be top 0. Then it's basically its x coordinate, which is top 1, and its y coordinate, which is top 2. Then finally iterate over its neighbor cells, but before that check if it is the target cell. If it is the case, if it is the target cell, then return the T or the elevation level associated with it. Otherwise iterate over its neighbor cells. So its neighbor, how can I iterate over its neighbor cells? For that I will be using these direction vectors, or let's say TR to iterate over the rows, that is -1 0, or let's take like a single vector, let's call it dr, let's call it dr. So 0 -1, the first pair will basically take me to the 0 -1, that is to the upper cell. Then 0 1 0. Fine, so up -1, that would, okay, it's not up, it's like left, then up then right, then down. Okay, fine. So let's iterate over the adjacent cells, and let's calculate the new cell. New x would be x plus dri, new y would be y plus dri plus 1. Now check if it is valid, that is if it is greater than equals to 0 and ny is greater than equals to 0 and nx is less than n and ny is less than n, and it is not visited. If it is not visited, if it is not equals to, if it is if it is equals to 0, if it is not visited. Okay, if it is the case, then that means simply visit it and push this new cell into the priority queue, that is grid the value grid nx and y and the new cell itself. Fine. So I think that's all, and finally at the end return -1. Let's just run this code. Okay, okay, okay. It's a vector. Okay, sorry, I have to take max of the current value and the previous value, so I have to take the max of these two values. Sorry for this mistake. Max of t and grid n x and y. Okay, max of this and this is, okay, I have to take max of t, max of the current value and the value till the previous cell from which I am coming. Okay, so let's just submit this code. Okay, that got accepted. Okay, let's discuss the time and space complexity. We can see that we are using a Dijkstra algorithm. We are using Dijkstra algorithm to solve this problem. So the time complexity would be same. That would be E log V, where V represents the number of vertices and E represents the number of edges. And we know the number of vertices would be n into n, and the number of edges would be 4 into n into n. So the time complexity would become n square log n square. This would be the time complexity, while the space complexity would be big of n square. Okay, because I'm using a priority queue. Fine. So that's all for this, that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel and stay tuned with me. I hope to see you all in my next video.